Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, today we are going to start with the structure of atom and mass number and atomic number. But before, let's rewind the last session. We studied Dalton atomic theory, in which it says that elements are composed of extremely small particles called atoms. All atoms of a given element are identical, having the same size, mass, and chemical properties. The atom of a one element are different from the atom of all other elements. If we talk about compounds, compounds are composed of atoms or more than one element. In any compound, the ratio of the number of atoms of any two of the elements present in is either an integer or a simple fraction. Fourth, we study a chemical reaction involves only the separation, combination, rearrangement of atoms. It does not result in their creation or destruction. We also studied modern atomic theory, which says all atoms are composed of subatomic particles, electron, proton, and neutron. Atom can be created and destroyed by nuclear fusion and fission processes. The atom of an element may not be alike in all respects as is seen in the case of isotopes. So friends, let's understand the structure of atom, which contain these three subatomic particles: electron, proton, and neutron, where proton and neutron are present in nucleus. So friends, let's understand where the proton, electron, and neutrons are. As the atom is built up of a number of subatomic particles, these are proton, electron, and neutron. Let's suppose they are the true structural part of the atom, nucleus and its empty space in where there is an imaginary path called orbits. Like this is an atom, the wall of an atom, and this is a nucleus. So here the nucleus contains the protons and neutrons. There's a structure like called orbit. As I told you, it's an empty space in where it's an imaginary path where the electrons move around the nucleus is called an orbit. These are the electrons. So let's explain. I shall give you the explanation. So this is an electron. This is a proton. And this is a neutron. And what the structure middle of the atom is called nucleus, right? Electrons have negative charge and protons have positive charge, right? Or the electron where it surrounds, there's an imaginary part called orbits, right? So let's explain the characteristics of these subparticles so that we can understand the structure. So here, let's we have electron, proton, and neutron, right? So let's start with the characteristics of electron. Electrons are basically very small in mass as compared to the proton. So it's basically electron from all the atom having identical mass, right? Secondly, we also say that it is subatomic part. Third, the mass of electron is 1 by 81837, the mass of proton. You can also call it 1. This is basically mass of electron. It also says the electron carries a unit negative charge of magnitude of 1.602 coulombs. Coulombs is the unit of charge. Fifth is also said that it is extremely so small, extremely small as compared to the proton, where the radius is 1 into 10 to the power minus 15 m. Right? Now friends, if we talk about proton, what are the characteristics of proton? Well, proton basically contains the positive charge, which have the value of, these are the positively charged particle, having the magnitude of 1.062 into 10 to the power minus 19 coulombs. Secondly, is the mass is the same as that of hydrogen, that is 183 times the mass of electron. We write electron like this. Third, the proton resides in the nucleus. That's the central part of the atom, right? As the proton are very heavily in mass, so the mass is actually the mass number of the atom, right? Now let's come to the neutron. Neutron are basically neutral in charges. They don't carry any kind of charge, either it's positive or negative. Its mass is basically 1.676 into 10 to the power minus 24 grams. It also resides in the nucleus. So these are the characteristics of the electron, proton, and neutron, where proton and neutron resides in nucleus, which is the central part of an atom, right? So let's come up to the main points. This is the red particles are electron, the purple one are proton, the neutron are the blue one. I hope you can understand now the structure of the atom. So let's remember these kind of points when you are dealing with the structure of atom. That the atom is the smallest particle of an element that can take part in a chemical reaction. The subatomic parts are electron, proton, and neutron. The entire mass of an atom is in the nucleus. So the number of electron is equal to the number of proton, always, for a normal element. Due to presence of proton, nucleus have the positive charge. As we know that neutron doesn't have a charge, that is they are neutral in charges. They do not carry any kind of either negative or positive charge. Hydrogen have one electron and one proton. It doesn't have neutron. The electron revolves rapidly in the circular orbital structure having certain energy, also called energy levels or shell. The atom of different elements contain different number of electrons, protons, and neutrons. So friends, we understood the structure and the subatomic parts. Now let's understand the atomic number, which says the number of proton in one atom of an element is known as atomic number of elements. And the mass number says the total number of proton and neutron present in the atom of the element is known as the mass number. Let's understand by this by a small example. So let's first write down atomic number, which is a number of proton is atomic number, that is for an atom, right? So it says the number of proton in one atom of an element is known as atomic number of that element. For example, if you see sodium, we write it like this, the symbol of sodium having 11 protons. So what is the atomic number? Atomic number will be 11, right? So all the atoms of the same element have the same number of protons in their nuclei. Hence, they have the same atomic number. The atom of different element have different number of protons in their nucleus. Since each element has its own fixed atomic number, therefore the atomic number can be used to identify an element. So if you see, this is a carbon. Carbon is having 6 protons. So atomic number will be 6, right? So what are the characteristics? First, this is a number of proton of a particular atom of an element. Secondly, it is used to identify an element. This is the atomic number of an element, let's suppose An, of an element is equal to the number of proton, as I told you. But it should be noted that for a neutral atom of an element, right? For example, one neutral element of sodium contains 11 electron and 11 proton, right? So the atomic number of sodium is 11. Atomic number is 11. So it is very important to know that here the atomic number of element is equal to the number of electron only in the neutral atom, not in an ionic position, because only a neutral atom contains equal number of proton and electron. On the other hand, if we see the ion is formed by the removal of electron from the normal atom by adding of electron. Either we add the electron or we subtract the electron from an atom, from the, we call it normal atom. Therefore it contains either less or more electron than proton, then it will be converted into ionic position, ionic state, you can say that, right? I hope you have understand now the atomic number. So it should also be noted that the atomic number of an element does not change during a chemical reaction. It does not change during chemical reaction, right? So let's understand now the mass number. So what is mass number? Number of proton plus number of neutron is a mass number, right? So now in the units, if you say mass of a proton is equal to 1 atomic mass unit, mass of a neutron is 1 AU atomic mass unit. So what will be the mass number? That is number of proton into 1 plus number of neutron into 1, which is the atomic mass. Thus, it is quite difficult to understand, but if we see in the simplest form, that the mass number of an atom gives us the atomic mass of the atom. That is, the mass of an element is usually denoted by letter A. It is denoted by capital A. So now we will derive a relationship between the mass number and atomic number of the element. Here we have, this is the mass number, which is number of proton plus number of neutron. Here we know that this is an atomic number, and this is a number of neutron. So this relationship should be memorized because it will be used in several numerical problems. For example, we have to calculate the atomic number, right? Whose atomic nuclei has a mass number 23 and neutrons are 12. So how will be calculating the atomic number? It will just simply, we have to put the values in this equation. That is 23, this is the atomic number, plus 12 neutron. So 23 minus 12 is atomic number. So what will be getting? 11. So here we know that atomic number 11 is of sodium, right? So let's understand now the characteristics of mass number. First, it is a summation of proton and neutron. By knowing mass number or atomic number, we can calculate the respective ones. Third, hydrogen will have the atomic number and the mass number same, right? So now let's discuss how we actually represent the element. This is the periodic table where we keep all the elements according to the atomic size and shape with the atomic number. So this is, we have taken the example of carbon where the atomic number is written here and atomic number is here and mass number is here. What is mass number? Proton plus neutron. Atomic number is proton. Here the atomic weight. We'll be discussing atomic weight later on the next sessions. Now I hope you have understand atomic number, proton, electron, neutron, and atomic mass number. So I want you to do this activity where I have given you a grid where there are 5 examples and many question marks. You have to just fill these question marks. I know now you can do it. So friends, in next session, we'll be discussing discovery of electron with the cathode ray experiments. So thank you for the wonderful session to attend this session. Thank you, friends.